Alright, so in this problem, I'm going to give you a sample that's similar to the helicopter problem on the constant acceleration classwork. So let's say we have a kid and they're jumping on a trampoline, and they jump up and they are, I don't know why their hands are attached to their legs. Anyway, they are 3 meters up in the air. And at this point, they are traveling at an upward velocity of 0.7 meters per second when they release a tennis ball they are holding in their hand. Okay, so at this position, they are going up at 0.7 meters per second. And they're going to release a tennis ball. And we want to know at what time does the tennis ball then strike the trampoline. All right. So what's important to note that both the kid and the tennis ball are moving at 0.7 meters per second at this position. So the tennis ball is going to have some positive constant velocity upwards. And it's going to fly up like this and then, fall back down towards the trampoline. So the other variables that we have is the initial velocity of the tennis ball, which would be 0.7 meters per second. We also have the displacement of the object. Now, I've been given a value of 3 meters, that's the height above the ground, but keep in mind that displacement is the change in position. So if we set our coordinate system here, this would be 0, and that means the ball is going to end up 3 meters down. So this needs to be negative 3 meters. That's a very common mistake. People put 3 there instead of negative 3, and we'll see how that messes up the problem here in a sec. And then we also have acceleration. Anytime anything's flying through the air, we have gravity, and we're just going to use negative 10 because it makes our lives easier. All right, so you see we have t is what we're trying to find, v initial d, and acceleration. So the equation that we have that eliminates the final velocity variable is that d equals v initial t plus 1/2 at squared. And it's a quadratic, and since we're solving for t, we're going to have to use the quadratic formula. So let's go ahead and just plug everything in first. So I've got my minus 3 is equal to 0.7t plus 1/2 of negative 10t squared. Now, in order to use a quadratic, I have to set it equal to 0. So this is where that minus 3 is going to make a difference, right? So I get 0 is equal to 3 plus 0.7t, and then that's minus 5t squared. So my a term is minus 5, my b is 0.7, and my c is a positive 3. And the quadratic equation is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So there are going to be 2 answers for the time. One of them is going to be negative, one's going to be positive. So the correct answer will be the positive number because that's the one that makes sense. A time can't be negative in reality. What that means in terms of our equation is it was the point in the parabola, or the time in the past where the ball would have been thrown from the hand of the person that was, if they were just standing on the trampoline. So we're shooting for finding our positive t term. Right? So let's just plug in. We get the opposite of b, so negative 0.7 plus or minus the square root of 0.7 squared minus 4 times a negative 5 times c, which is 3, all over twice a, so negative 10. Now, a lot of times, if you didn't take into consideration that 3 meters down and make it negative up here, you're going to get an imaginary number here. You're going to get a negative underneath the square root. So that's another sign that, maybe you did something wrong at that stage. So if I just go ahead and solve underneath here, I've already done it, you get 7.8 for the square roots. You get negative 0.7 plus or minus 7.8 all over a negative 10. So we're going to divide by a negative number on the bottom, and I said overall we're shooting for the positive t term, so we want it to be negative up here as well. So I will actually have to use the one where we subtract, right? So 0.7 negative minus 7.8, I get this, negative, and then divided by negative 10, so I get 0.85 seconds. So that's my answer. Now I could look and see, well, if I take negative zero point 0.7 plus 7.8, I get 7.1, and then divide that by negative 10, so my other answer would be negative 0.71 seconds. So that's the answer that doesn't make sense, right? So in this case, we know that the ball is going to strike the trampoline 0.85 seconds later.